Hello everyone, welcome to Hydra Beginners Tutorial, and in this video I will cover the last bit of functions, which are the audio reactivity. And I know this is like a big topic and some of you are super excited. Sorry if you are really excited, I might not go too deep into it because I did some tests and it's actually quite tricky how to get, how to nail things. And personally, I'm not super like a big fan of using like feature extraction and so on, because when I work with audio reactivity, I often just do like synchronized BPM and or even not synchronizing BPM, and it kind of works. This is a really interesting topic. I think how like perception works. That is like we try to like as a programmer, we want to make for example, the visuals like reacting like perfectly aligned to the song, BPM, the beat, but like even if it's like not really synchronized, sometimes human brain try to like correct them. So what I want to say is this is like one way of working within Hydra and using the microphone and pick up the sound and using that as an input. That's one way of like kind of easy way of working, but it's not the only way. And also like the setup I have, it's a little bit tricky. It's not like in a club where you have like blasting sound, which is quite different in from the setting I have, and the microphone cannot really pick up the song nicely. I know there are like alternatives. For example, I don't know if it's like Soundflower or like these tools that internally you can wire from the sound source to a virtual input and so on. And if you're like knowledgeable in this, please like go ahead and try them out. But I'll just do like very simple setup that I have my laptop, which is playing the sound, and the microphone of the laptop is going to pick up the sound and do some calculation and affect the Hydra visuals, which is quite noisy, but it sort of works. But also like it depends really on the songs. And I think what I want to provide in this video is that how to, basically how to do the programming part, like basic part, and also like just look into like what works and what doesn't work, because depending on a song, it might be like very effective, but it might not be effective. So we'll look into like kind of, like very simple setup that I have and see what works and not. So, and I think it's important that you check out the previous videos, because I'm going to be using this array function kind of notation that I can use the audio variables or variables from the audio detection directly into the Hydra functions. So I'm going to shrink myself as always, and let's see. Let's always like go back to this Hydra functions, and we covered most of them. I mean, I skipped some of the functions, but basically all the categories are covered, but the last audio. There are a few, and I will not talk so much in the settings, because again, some things work, some things are just confusing, so I'll like briefly mention them, but not into details. First thing, it's actually grayed out, which is unfortunate, but there's this hide and show functions. And the way you use audio functions is, let's go to the editor and just blank. I just hit the bin, and actually it's already showing. Well, actually I have to move myself because, so the way you use it is a.hide, a.show, a.fft. It's always like a is something special that Hydra provides you, and in the video recording I will move myself into the other side, because, and also I have to shrink the window so you can see this part, because what's going to happen here is actually, so I was showing it, so I'm gonna hide it first, and then I'm gonna show, and I might want to adjust this a little bit so it's not distracting. Okay, so a.show, just do Control Enter or Control Shift Enter with a.show parenthesis, it will make this little like bar chart kind of thing, visualizer on the bottom right corner of the editor. And as I talk, this is like already picking up the microphone. So one thing important is that you enable microphone when you open Hydra editor. And if you haven't, if you forgot to, or if you canceled it, you can always, like, for example, on Firefox, you can click on this microphone icon on the address bar. I already allowed it temporary, but also it can be like blocked temporarily. Also, like, this is useful when you want to switch to another device. So you cancel it, like press the cross and reload the page. It will go back to original. But then this is something that I often like block it. But this is something we need today. And for my case, I will use MacBook Air microphone because I want to use the embedded one. And if you have like virtual sound inputs and so on, this is the place you want to set. And allow camera. I'm not using this for now, for today, or we might use it. Okay, so let's just do it again. A.show. So we have this like little bar, and as I talk, this is like already picking up from the microphone and kind of visualizing, quote unquote, my voice and environmental noise and everything combined. So if you tap, that also is picked up. See, so these things are like, already input to this A object. Well, not an object, but A, like as a text, this thing here, A. So I'll just do like basic stuff. For example, OSC. Normally I would do, well, maybe I'll make it a little bit less slow, grayscale, out, something like this. And what I want to do is to change the color of it using this A object. And as we saw last time, it's not, the way it works is A.FFT. This is an array. It's a little bit confusing, but maybe just like, try what I have here. But again, just like we use a time variable, if we do this, it's going to be like frozen at the time when you evaluate it. So you want to have this parenthesis and equal and greater than to make it real time, so that every time, every frame, the Hydra function will check A.FFT 0 variable and update it so that it's not going to be frozen. Now I'm going to evaluate it. So what's happening is you can see like a small, very subtle change when I talk, that it goes to like white, because, okay, maybe this is not the best option. I will say 0, 0, so that red channel is dictated or manipulated by A.FFT, which I will explain you later. Let's say it's like a kind of volume for now, and which actually is one of these, like the bar at the leftmost bar is the A.FFT 0. And let's suppress green and blue channels so we don't see anything. But when I talk, it will kind of like light up. So it's very like basic setup, right? And if you think this is not enough, the color is not enough, we can always amplify it by multiply by 4. So now it's interesting because even if I'm not talking, it's picking up the environmental noise because there's a fan and there's things around that's making noise, and you can see that it's affecting the color even if I'm not talking. But the idea is that, this can be like a media installation you want to make with, someone talking to the microphone and make visualizing with Hydra. That's great. But often what you want to do is to play a song, or there's a DJ who's changing the song, crafting the song on the spot, and the visuals will be triggered or reacting to the beat, for example. So in order to like demonstrate, I chose some songs. Well, I just picked like 2 of them from freesound.org, which is an amazing platform where you can or well, you can actually upload your songs, and also you can download other songs, and it's free to use. There are different licenses, but for example, this one is Creative Commons 0, which means that I can use it in any way. But I will link to in this description down below. I link to this URL, which I don't need to, but it's kind of nice to do it as a practice. So I'm doing it, and what I'm gonna do is just play it in loop, and I'll just like try to lower the volume for now. And I like deliberately chose this kind of drum and bass type of loop because, well, is there bass? Well, anyways, the drum loop, because it's easy to work with, like to detect beats. Because I chose another one. So, well, let's see. Like, I'll just like play it a bit louder and see, and I will shut my mouth and see how Hydra is gonna react with the same code. So what's interesting here is that I'm gonna stop the loop. The audio package internally, like it's not like Hydra, like made for Hydra, but Hydra is using the audio package, NPM package, JavaScript package called Meta, and Meta is kind of like smart detection, like doing some kind of smart detection. So right now you see like all this, even if I'm not talking, you see this noise, but when I was playing sound, it's kind of like balancing out the beat and the silence. So it was like when like between the beats, it was quite clear that the color was suppressed. I can do it again. So you can see that I also changed the number to 10 because I thought it amplifies a little bit better. And this is something that you can change according to your setup, your song, and so on. And probably like you want to like manipulate it on the spot. Now, what is this A.FFT0, which is basically, if I can go a bit bigger. So you see these like 4 bar charts, and these are it's kind of like equalizer kind of thing. And Meta does like kind of equalizing internally, so it's not changing the sound, which is like played back, but the result is like kind of affected relatively to each other. And here we have 4 bars, and if you say A.FFT0, which is the leftmost, and A.FFT1 is the second one, again we start with 0, so 1 is the second one, 2 is the third one, and A.FFT3 is the fourth one, the rightmost bar. And what does it correspond to? I mean, if you're familiar with like this kind of audio processing, probably you get the idea already, but it basically corresponds to frequency. And intuitively, I mean, when I say frequency, if you make like higher pitch sound, that corresponds to higher frequency, and lower frequency goes to the left, close to the left. So this like pitch da da, that changes the which bar it affects. But in reality, that is correct when we're making pure sine wave tones. That's why I love OSC. Well, it's kind of related actually. But anyways, we're not making pure sine wave. I mean, you might want to make that kind of sound piece. That's also a nice way to approach sound, I guess. But in general, like if you're talking about like songs, like in a way that like what I was playing for now, for example, that contains like a lot of different frequencies, and the worst one is the white noise, which is like shh kind of sound, which I can actually try to see this these little bars. you see that the actually the ones on the right are affected, but it's not just one bar, but every bar, all the 4 bars are changing at the same time. That is because that sh sound contains different frequencies, which is quite interesting. So it's actually interesting, but also for us, it's kind of annoying because we cannot just like pick, okay, this like boom beat is like 1 bar that is FFT 0, and boom is like FFT 2. It's sort of, but not clearly. They're like kind of contaminating each other. But you know, that's the world we live in, and that's what we work with. And if you want to like make this kind of like clear corresponding like clearly, then you have to work with, like, for example, like if you use strudel inside Hydra, you can somehow like map these like nodes as like events in Hydra. I think that's how you can do it, but I don't work with this personally, so I mean I don't have skills in that, so I cannot tell you further in that. But for now, let's keep it simple. We just have this, you know, loop playing in the background and see what we can do with it. And now, like for example, if you listen to this, yeah, so there's at least like 2 different percussions. So I can, what if I do like same but FFT, but 1 this time. So what you can see here is that when there's like lower, like this like bass kind of sound, you can see the first part is reacting more, which is A.FFT0, the leftmost, the lower frequency. When this only this one is triggered, then the color should be like red, and because it's the red channel. And if more like a percussion with like higher pitch is triggered, then this is more how to say, responsible. So A.FFT2, no, A.FFT1, which is the second bar, that's like a bit higher frequency. And if only this one is triggered, then the color should be green. But what we observed is like sometimes like with this like lower like bass sound, it's more like red. But then another percussive sound, it was a bit more like yellow because both of them, these 2, are triggered. And of course you can like try to isolate them by, what if I make a difference between, because you can make these kind of mathematical notations, so you can subtract 0 from 1 to make a bit like clearer difference what's going to happen with this. Let's see. Oh, but then now it's, as you can see, it's if A.FFT0 is bigger, then it becomes negative, and it's making this funky color, which is kind of also funny and nice. So let's see. So it's kind of working, but not exactly. We don't really distinguish like 2 different color palettes. So that's where like I kind of see the like limitation of this approach. I'll just keep it like this way, or even yeah, I'll just keep it this way. But this is something I see that it's a limitation. So it's easy to like kind of trigger this kind of like bang, to trigger something as like kind of very like minimalistic approach. If there's like any sound, then trigger color. That's feasible, let's say. But if you want to like start like distinguish different tones, different percussions, and so on, that's very tricky. And even if you have like machine learning stuff to isolate these sounds, yeah, maybe it's possible to do this kind of thing, but after all, like connecting to, you know, the sound source, I don't know if it's a strudel or if it's Ableton Live, I don't know how to combine them, but probably you can send MIDI from Ableton Live and receive it in Hydra, or this, like, you can make some kind of proxy between them and make OSC from MIDI, or I don't know, this kind of thing may be possible, but that's like it's possible to do, but I'm not going to explain in this video. And again, like that's also like really like case by case, you know, like what kind of tool you're using and so on. So I'll just like, I would say it's basically like use this to kind of, you know, detect this like onset and do something, like just keep it simple is probably the way to go, at least to me. And maybe like if you know the BPM of the song, you can use the BPM parameter that I shared with you in the past, in the previous video actually. You can like combine these like two different tricks or techniques so that your sequencer inside Hydra is changing with the BPM of the song, and also using a.FFT 0 to trigger some kind of more like organic effects, because this sequencer is a little bit harsh, which I can actually try, because in this song it says 76 BPM, and what I can do is BPM equals 76, and okay, let's keep it like this, and then I don't know, it's a little bit harsh, so let's do it like this. So it's just red is changing, and I don't know, maybe like layer or something with shape. If you do this, oops, I didn't do dot here, and it's gonna just overlay completely, so you have to do luma like this, and then I don't know, maybe like rotate. That corresponds to the BPM, for example. So 0, 1 point, I don't remember by heart, but pi divided by 2, and go back to 0, and pi, for example, close the array. I think I want to make it a bit faster, but let's hear the song and see what's gonna happen. So what I tried now is that basically I'm using this trick technique with a.FFT as a background, as backdrop, the OSC, and because I know the BPM of the song, I use this BPM 76, and the layer here, which is like overlaid on top of the OSC, which has the shape that changes the rotation with the array, which I explained in the past, in the previous video also, that has like 4 different values, which changes from like no rotation to 90 degrees, 0 degrees, 180 degrees. And because if you use BPM, it's actually the beats there are beats between the BPM beats. I don't know how to say. They're like the sub beats. I don't know how to call it in music, but normally it's better to like make it faster, or you could just multiply it BPM. But you know, either way that works for you. I also use the offset because Hydra knows the BPM, but it doesn't know like when it is actually starting this song or the beat. So I just like offset it and manually so that it feels right. It's just manually. So every time you play the song, you might need to adjust this offset. It might be 0.1, it might be 0.5, 0.9, something between 0 and 1. So, and also like there are like different functions to change, for example, like the settings of a object. For example, one thing might be useful is set bins, which is basically, I can run it here, and oops, a dot set bins, and default is 4. That's why we had 4 bars for bar charts, bars in the bar charts. But if we say like 8, then you can actually see it already changing here at the bottom right, that you have 8 bins. But I have to be like really like cautious about this, because having more bins doesn't mean that you can isolate different tones. And as I said, like there's like a lot of contamination between different frequencies. So unless you're like really like playing pure sine waves, I think 4 is okay, or even like 2 is probably enough for our purpose to kind of trigger this kind of like changing the amplitude of changing the like brightness of the texture based on like this input of this bang. Then set bins 2 or default 4 is probably enough, and I'll just use a.fft0, and I might use a.fft1, but I'm not gonna like I don't have this hope that I can isolate 2 different sounds, pitches. So it might be disappointing for you, then I'm sorry, but I think what I demonstrated at the end makes more sense, that you use the BPM and the a.fft so that you can kind of like layer them and make them a little bit more complex than the visual like result is more like complex than actually what it's doing, which is kind of interesting. Like to me, what's interesting is to trick the brains of the audience rather than like really trying to wire this MIDI from that to OSC this and that. Oops, I think it froze, but actually, oh no, it came back. I thought like it's actually better to be frozen. But anyways, so like again, there are different ways to like craft audio reactivity, but we just saw like the very basic one, which is a.fft, and also using BPM. If you have suggestions, if you have techniques that you use or tricks you use, please share in the comment down below. And also, like, I did more like sophisticated audio reactivity in the past, and that was more for like recording, not like live playing it live. But in the advanced videos, I might go into these topics if you're interested. So please let me know if this is interesting for you, you want to know more about it, or if you're not interested, or if you have like other topics you're interested in, please let me know in the comment down below, or I put my email address on the bio of YouTube, so you can find my contact there as well. And yeah, I think I covered everything, and I don't know if I brand the next video as a intermediate tutorial or a continuation of beginner's tutorial, but finally I want to go into the topic of the feedback. Let's say this is intermediate topic. And I know like you're all like interested about feedback, so I would love to like spend a few videos on that topic. But by that time, thank you for watching. Please like the video, subscribe to the channel, and I hope you have nice coding. Bye.